Hello and welcome, and thank you so much for joining this special event built on AWS, covering our solutions, our AWS partners, and our AWS software vendors come up with. I'm so excited to be joined today by Aerospike. We're going to have a great discussion today about in the database realm, specifically covering things like high performance distributed NoSQL database systems, talking about design patterns for real time applications that demand exceptional speed and reliability. But first, let's do some introductions. And let's start with our chat. We've got tons of people joining today. I'm really excited about, I think we're streaming on Facebook, we're streaming on YouTube, we're streaming on LinkedIn, and even X, formerly known as Twitter. So go ahead and introduce yourself in the chat. Where are you joining us from? We always love to see all of the different viewers that we have. And this is an interactive live stream, so we'd love to hear from you. First off, let me introduce myself. My name is John Marciniak. I am a senior solutions architect at AWS. I've been here for about 7 years now, and I'm really, really excited to have Zohar with me. Zohar, would you like to take an introduction?
Yeah, sure. Thank you. Nice to be here. I am happy to be here. My name is Zohar. I'm a principal solutions architect with Aerospike. I've been with Aerospike since 2018. And before Aerospike, I did 20 more years of databases. So SQLs and NoSQLs. I was a consultant and a DBA, and before that, a developer. So pretty well versed with the databases.
Yeah, it sounds like it. Looks like we've got some folks joining in. We've got some people from YouTube from Raleigh. We've got folks from India. We've got folks from Argentina, all over the globe. Dubai. Seeing somebody else from the Chicagoland area. Always like to see that. We've got Omar here. North Carolina. All over the place. Angola. Beautiful country. Been there myself. Let's get some. I'm so excited to get started, and we have a lot to talk about. Once again, this is a live stream. We are streaming. We do have some dedicated chat subject matter experts, some dedicated chat SMEs that are in these in the chats from both AWS and Aerospike. So if you have any questions as we go through this, please reach out. We're going to be highlighting some of these questions and bringing them up, talking about them live. So feel free to do that. And especially just to kind of get us kicked off here, thinking about databases, thinking about database systems that are supporting real-time applications. Like, I feel like there's a lot of definition on what real time actually is. Like, some people think of real time as it updates within a second or a couple seconds, and then there are, I think, some like real use cases where real time means like within milliseconds, right? And so I'm really excited to hear a little bit more about Aerospike and Aerospike's journey towards high throughput real time applications. Can you tell us a little bit more about that, Zohar?
Yeah, you touched a really interesting point, because when people talk about real time, it's really ambiguous. So people think about real time, like the majority of people, when you talk about real time, immediately go into embedded chips and fire jets, jets that are flying in the sky, and everything is really, really here and now. They need the immediate information, and after that they forget about it. They don't really care about it. They only interact with what is in actual real time. But real-time system and real-time data systems are slightly different. They need information right now, but they need information from the past. They need they have a lot of data that they need immediately. And that's an interesting part. And that will be what we're going to talk about today, because essentially Aerospike is a database. And this is what we're going to talk about, the way that real-time systems, or when we give examples in a minute, are actually interacting with their data.
Yep. Yeah. And we've got some comments here rolling in. Real time is a funny word for crypto. There's a lot of different industries, like financial like fintech kind of industries. And I know like, serving ads, advertisements on the web usually needs like really real time, like within making decisions, doing really complex computations in milliseconds to serve the right content. Really interested to kind of get into some of these industries, and for those of us watching, if you're in one of these industries and utilize real-time databases, real-time decision making, please let us know, what industry you're from, and how real-time databases is a huge importance to you.
So let's give a couple of examples for those kind of industries so people can relate to. So you mentioned AdTech, and AdTech is really interesting in that sense because it sounds really weird, but AdTech is really in the real time, the internet real time, where you actually need to serve an ad in matters of hundreds of milliseconds, sometimes as low as 100 or 150 milliseconds. So in that time span, an application or a company that wants to show you an ad needs to understand who you are, what you're about, what you like, what will be an appropriate ad, what will be an appropriate amount of money to pay for that ad, and then to show you that ad. So this is like really critical in the sense of really high throughput and low latency. But there's
Yeah.
other places like gaming and fraud detection, as you mentioned, and AI is pretty interesting right now and trending. So there's a lot of areas where real-time data is actually really, really important.
Yep. And I actually had a brief stint in the ad tech industry early on in my career. A lot of things have changed since then. I feel like there's a huge weight towards real time video ads, and distributing video ads that are relevant to the end user. And that, when you think about it, like it has to make decisions about who that person is, and then load up the right video, and then stream it in real time, right? You don't want that lag between when the normal video cuts out and the ad starts, or the pre-roll ad, or something like that. But even in kind of what I say is the old school kind of display ads or text ads, there was a lot of there's a lot of complex kind of inertia in delivering those types of ads as well. So it's really interesting to see how our infrastructure evolves as time evolves, and certain needs evolve, as well as industries evolve.
And it's even more interesting because behind the scenes, so much is happening that people are not aware of. So
Yeah.
unless you've actually been into an ad tech company, you don't understand that there's an actual bid, there's like a competition on the ad that you're going to see. So from that sense, it is as much information as you can get on the people that you're going to sell the ad to, and then as much information that you can squeeze into that really, really short period of time, that makes the difference. And if you look at that and you think about that and you understand that this is an actual challenge, this is the actual technological challenge that companies face every day. And again, we are talking about ad tech, but it's relevant to a lot of organizations.
Yeah, I think we might be having some video difficulties here, but let us know in the chat. Like how do you approach real time applications? I think you're back. Are you back, Zohar?
I'm back.
All right.
Can you hear me?
Yep.
I'm good. Okay.
I see one comment in the chat that I want to address right now. Is this event recorded? There's the one. Yes, this is being recorded, especially I think on platforms like LinkedIn, other platforms, maybe YouTube, but definitely the LinkedIn. We'll get the LinkedIn links out, and this is on demand. So after the stream ends, you can go back to the same link on LinkedIn at the very least, and be able to see this. So yeah, you can come back to this and see it again. So yeah, thanks Chris for that. Why don't we get into a little bit of Aerospike and your position in the market? Was there did we want to share anything on that to kind of get this kicked off, or?
Yeah, so let's talk about what Aerospike in a nutshell is. If you can pull up the couple of slides that I prepared.
Yeah, let me do that. There we go. Should be able to see that.
Yeah, if you can see. Okay, so Aerospike is a real-time database. So in a nutshell, when we talk about Aerospike, we talk about a system, like a database system, which is built for mission-critical systems. It's distributed, it's high throughput, it's low latency. But the most interesting part about it, and I will talk about it in a second, is that it never caches anything. And I'll explain what it means. So if we try to break down the buzzword about Aerospike and what we actually are, we're a NoSQL database in the key access pattern. So think about key value or document. But in that sense, we're slightly different because you can keep multiple values for the same key. And you can have those values as like different kind of things. It can be scalars, like integers or strings. It can be complex, like hyperlog or GeoJSONs. And it can actually be documents. You can actually store lists and maps and nested lists and maps. So it's really interesting to see what data is being served, even in real time. In the other position for that is that we don't only do key access patterns, we also have secondary indexes. So it's much wider than that. The second part to know about Aerospike, it's a distributed database. It was built as a cluster from day one. So it's really scalable. It's built with multi-threading. It's built with multi-core approaches. It's built for multi-nodes where you can actually scale up and down the cluster. And it would make sense because this database is primarily built for high throughput. And when I talk about high throughput, I talk about tens of thousands, hundreds of thousands, or even millions of operations per second at a latency that is counted at the milliseconds. So a single digit and often sub 1 millisecond. And we will see a demo for that, a live demo for that later in our show.
That's
The
go ahead.
really, really cool part about it is that we do something that is unique. We allow you to get those high throughput and low latency at any scale. And that is because we don't actually cache anything. So if you think about how this world works for the majority of the databases and organizations, when they think about low latency, they think about persistent data at low latency, they think about some persistent layer, and then like a cache on top of that. The more data that you cache, the more data that you can serve quickly. With Aerospike, nothing is being cached, no data is going to memory, but you still get the latency of a cache system.
Yeah. And I think one of the it's almost perplexing because I see on this slide here, it seems like you get everything that you would ever want, and it's no cache, like it says on the bottom here, delivering in-memory performance on NVMe or solid state drives.
Mhm.
So it's almost like what is the secret sauce? How does this thing actually work? How can it not use some sort of caching layer? Really
Yeah.
interested to kind of learn about that.
Yeah, so this is our patents. This is the way that we revolutionizing the world. This is the innovation part of Aerospike. And I will explain, there's no tricks here. We actually figured a way to store some indexing in memory and all of the data on an SSD or an NVMe.
Yeah.
And through our different components of the database, we actually allow people to fetch the data from the disk very quickly. So there's no tricks about it. There's no magic, like no black magic or voodoo behind it. We actually created a really sophisticated and interesting technology that makes sense to that.
Yeah. And I think, there's some advantages there about having the data on solid state drives when it comes to,
Mhm.
being able to scale quickly on the NVMe kind of storage layer instead of having to replicate caches. So I think that's uh, very interesting to think about from an architecture point of view and being able to utilize that at scale and be able to grow your cluster as you need it.
Basically, if you think about it, these are way cheaper than putting data in memory.
Yeah.
Think about the cluster that is a terabyte in size, with another terabyte for the replication factor for redundancy and durability. When you need to keep 2 terabytes worth of data in memory, that's really expensive. And if you need all of the data available for you because you need it at a sub 1 millisecond latency, that becomes the hassle. That's become a real technological problem. So in that sense, we have customers like AppsFlyer in Israel that is storing 1 petabyte of data in a single cluster, doing 10 million operations per second, read and write operation, and mixed workload from disk. They don't need any memory. That's a single cluster at a sub 1 millisecond latency at the P99, the 99th percentile. So that is a really interesting way to think of the world, because once you think about the ability to scale your data to the extremes, this is changing. This is changing technology. This is allowing customers and people to do way more. It's really niche because it's like real time and data and so on. It really is a database that changes the world.
Love it. Should we go on to the next visual here?
Mm-hmm. So the way that we actually think of the database is the core component of our system, but we are actually more of a data platform. So we have the different data models that you can use. So the key value that I mentioned and the document. We also have a graph component, which allows user to work with graph identity resolution stuff. So there's a lot of things about that. But in the sense of the database itself, most of the components, most of the internals are really like hidden from the user. So once you do you connect to the database, the transaction engine that allows you to read the data is hidden. You don't need to do anything about the replication. The duplication of the data across nodes is being done by the database. When you need to query the data, it's being done by the database. If you need, even sharding is not something users needs to do anymore, because the database is auto-sharding the data, and when you need to scale, it will automatically move the data around. And once you go out of that and you think about that as a core component, you can understand that we can connect different streaming applications and streaming both upstream and downstream. So let's think about Kafka, for example. Kafka is really popular when it comes to real time. Kafka is a message broker where you put data in topics and read them and consume them and produce data into them. Is something that we work very natively with. We can consume the data from Kafka and put it into the database, but we can also produce data from the database and into Kafka topics. On the other side of things, there's the consumption of the data, for example, Spark or Trino for SQL queries. So we created like a database that makes sense for the real-time world, for the low latency, high throughput. But then we decided to be a team player. We decided to be part of the larger like infrastructure or data pipeline and connect everything together. And that's really important when it comes, because the database is just a single component out of like many parts of it.
Yeah, and that's, I think, a really interesting point. The data just doesn't have to end up and like sit at the very end in an Aerospike database. It can also be kind of the throughput engine as well, from your streaming connectors, and then on the other end, and any kind of data warehouses or data lakes that need to interact with it as well.
Mm-hmm. And this is all being done in real time. So let's say that you have data that is, let's say, user profiles, for example, and that's the example that we're going to show in a second. So if you think about the user profile, for example, then you want to use that information that you gathered in real time from your endpoints and use that in your Spark applications, and vice versa. You created some information about your users and you want to dump it back into the database for your front end to interact with.
Yep.
So it's really important to be a team player, to be part of a larger infrastructure. And I think this is one of the most powerful things there is. And at the end of the day, we're talking about the software. So Aerospike is strictly software. We're not selling any hardware. We're not selling any accelerators. It can be deployed on AWS. It can be deployed on someone's bare metal. You can use Kubernetes, but it can also run in a virtual machine. So there's really flexibility, but at the end of the day, it's a really cool technology that is strictly software. There's nothing hardware optimized about it or hardware focused or oriented. It's optimized for SSDs and NVMEs, and we'll talk about it in the next slide, but it's not something that we need someone's specific NVMEs, for example. The better the NVMEs are, the better performance that you can get out of the database.
Yep, love it. We do have a couple of questions here in the chat. Is now a good time to kind of bring some of these up?
Sure, go ahead.
So, and I think this is relevant. Well, this is relevant. We've got one that says, does it support Windows platform? This was a few minutes ago, so maybe there's a better understanding now. But still, I guess the question remains.
So Aerospike is a Linux product. It's something that's run on Linux. But if your clients are using, let's say, .NET, they can connect to the database. We have a client for .NET. So you can create your application on that, but the database will still need to run on a Linux machine.
Yeah. And then on the left-hand side of this slide, I see, all the different data sources, and I'm starting to see some of the use cases that you support. Like I see gaming, I see, social, things like that. And then this question came up, more of a comment, but like healthcare industry can also really benefit on this as well. Have you seen a lot of healthcare industry type use cases come across?
We have several customers in the healthcare industry. So,
Excellent. Should we move on to the next slide?
Yes.
All right.
So I put here the slide for just to understand the architecture, because what I said before, not having memory as a caching layer, is something that sounds absurd to most people. If you're into applications and databases, not having a memory cache of data sounds kind of absurd. And in that sense, Aerospike has some unique architecture. But it's interesting because this architecture thought about being high throughput, low latency from the very beginning. So if you think about where the database starts, in our mind, the database doesn't start where the database actually deployed. It starts in the clients. The client has smart capabilities where they can actually fetch some information about how the data is distributed across the cluster. So they will be able to skip any intermediates and proxies to get the data to get to the data quickly. So when you need to read a record, the client will automatically know which shard you need, and you to know where the shard is. And then there's a direct path to the data. And when it gets to the server, then the real-time transaction engine takes over. It understands what is the record that you're trying to, for example, read. It understands where to get it from. It reads it from the disk. If it's a write, it knows how to put the data on a replica. It knows how to make sure that you're getting the latest version of the record. So there's a lot of engineering abilities were baked into the database to make that thing completely transparent to users. If you take those two components together and think about them as like one set, from the user perspective, they know nothing about the cluster structure or how the structure look like. Okay, so they work at it like it was like a cloud of data. From their perspective, the data is there and it will always be there. And if the cluster changes, then the data distribution engine from our side, from the database, would move data around without ever resharding or rehashing the data in order to move the data into new nodes and distribute the data across all of the nodes in a uniformly sense. So from the backend perspective, from the DevOps engineers and from whoever looks at the database administrator, for example, everything is always balanced. The data is balanced, the transactions are balanced, everything is balanced. And from the user perspective, they care nothing about that. The smart client makes sure that they move around with the data. There's no concept of data locality because of that. There's no concept of finding the right sharding key. A lot of the things that engineers and developers struggle with is something that this database solves.
Yeah, and I think that really kind of touches on it from both sides. At the end of the day, you don't want the end user to have to, think about or see any kind of delays, which really means that making the database manageable from the DevOps side and all the balancing that you talked about is really important. Also from the DBA side as well. And then all of there's so much complexity in that we don't think about, like the sharding and having to find the right shard and all of these things that add up in that response time. And if you can eliminate that, I think that's sort of the key and the right thought process to make it as fast as possible and create, a simplified as possible version in order to think about, what really matters, and that is speed, right?
Right, and think about that. Think about it like that. You want your users or like the developers to focus on the business. You don't want them to be focused on your technology struggles. If you give them a database that allows them to do low latency and high throughput, and that's guaranteed, and we'll see that in a second, then from their perspective, what they need to understand now is how to implement their business logic better. They won't need to think about how to architecture their data in a sense that in a way that would make sense later when you scale up. One of the things that we saw with our customers over time, that while you scale with the database, you don't need to ever re-platform. You never need to change the way that you write your application, because you're never in a sense that there's no place where things degrade. Performance don't degrade when you work with the database. And that's a really unique proposition, because most databases need some kind of maintenance. They need a way to, let's say, rebuild indexes, or they need a way to make sure that things don't go away. And even more than that, when you scale even either up or down, a lot of those systems needs to reshard or to rebalance the data by like reading the entire data set and recalculating where things needs to go.
Yep.
But this database did that for you. This is really completely hidden from the user, and that is like a wonderful thing for developers. And this is like an awesome thing that we see.
Yeah, absolutely. Yeah, the more maintenance that a database requires, the more there's that push and pull between risk and resiliency and things like that that you have to worry about. So really, really cool uh, that a lot of that is behind the curtains for the end user of the database.
For
Um,
everybody, essentially.
yeah, yeah.
And it's even more interesting than that, because if you think about people saying, yeah, scale, we will scale someday. But we're coming up on Black Friday next month, right?
Hmm.
And this is like the celebration of the internet. So Black Friday, Cyber Monday, everything booms. Like all the ad tech is booming,
Yeah,
every e-commerce is booming, and now they need to scale up. And then by January, everything like settled down, and now you need to scale down. And then what you do?
yeah.
You're in some of those systems, you're cooked. You have a problem now. You can't really scale down, and that's the interesting part, because you can scale up and down, and that doesn't matter. We figured a way to make that work very seamlessly to the applications and to the users.
Yep. I'm starting to already get holiday magazines and like catalogs and like the for me here in Chicago, the weather just started to drop. So I'm starting to kind of think about that holiday season, at least here in the States. Um, but let us know in the chat if you're starting to see, a lot of holiday stuff roll around, and maybe you think it's a little bit too early for that. If you agree with me, go ahead and let us know in the chat. If you did just join us, we've been chatting about Aerospike, which is an AWS software vendor, talking about high performance distributed NoSQL database systems, real time applications that demand exceptional speed and reliability. Thanks so much for joining us. If you do want to rewatch this on demand, you can visit the LinkedIn link. We'll throw that in the chat. We did have a couple more comments. Is now an appropriate time, or should we kind of press on and maybe collect them?
Let's take some questions, and then I'll explain the secret sauce.
Okay, sounds good. Ooh. So the first one, very straightforward. Is this leveraging ZFS?
The answer is no.
Okay.
We use like our own file system, we use raw devices, and that will be in like 3 minutes. We'll talk about the secret sauce, and that would make more sense.
I'm excited. We have a couple from Savitha on LinkedIn, so I'll bring this one. It's sort of a long one. How does Aerospike maintains sub-millisecond P99 latency when ingesting high throughput streams from Kafka and Pulsar, especially for mixed read and write workloads?
So there's a lot of engineering abilities that were baked into the system, and I'll explain the secret sauce in a minute, and then I'll touch on this specific point. Because looking at the mixed workload, that's something that we specifically thought about and engineered the system around it. We thought about mixed workload as something that is essential for. So we started as a solution for ad tech companies. We branched and grow from there. But from that perspective, mixed workload is the bread and butter of ad tech. They will need to read, write, and update their data all the time. And in the demo that we'll show in a minute, we'll do a mixed workload of 500,000 operations per second.
Wow. Okay. And then we had one more from Savitha that I'll show right now. Maybe that's relevant to in a little bit. For DevOps teams, what metrics or tools exist to visualize how the database is distributing and balancing data behind the scenes? Good one.
So we have two kinds of dashboards that we're providing. One is Grafana and the other one is Datadog. And we have an exporter from the database that allows the DevOps and the monitoring teams, the NOC teams, to get as much information on the database that is possible. So we export everything from single operations to latencies to metrics on literally everything. We understand that reliability is a really important part for mission critical systems. And therefore we provide a lot of information. In the demo, I will show the Grafana dashboards, but there are also Datadog dashboards equivalent to them. And that will give you some aspects of what information you can derive from the database while it's running.
Nice. Then last question, I'm really excited to see this demo. This one just came in. What strategies does Aerospike use to maximize latency for real-time analytics workloads in a cloud-native setup?
So Aerospike isn't really an analytics system. It's more a key-oriented system. So you think about it like a primary key access, basically. So when you need to reach a single specific record, Aerospike does that in a really, really efficient way.
Yeah.
And if it comes to analytics, we can do secondary index queries and read a bunch of data, but Aerospike doesn't do aggregation, for example. You need user-defined functions for that, and you need to aggregate the data yourself. So we kind of focused on the things that Aerospike is really good at, and kind of the rest of it is out of our realm, out of our playground.
Yeah. So I think of key value, I think of document, and I think of graph, which I think especially is a lot more prevalent these days with agentic workflows and graph rag and things like that. So really interesting to see how those aspects play into the AI aspects play into that. Maybe we can talk about that a little later. But I think what's really the burning question for right now is can we see a demo of this?
Yeah, so let me explain about the secret sauce for a second, and then we'll touch on the demo.
Okay.
So secret sauce here is something pretty unique. Most databases that go into the mega scales in terabytes and petabytes use some large merge structure. So they'll have the data and they'll try always to compact it and to reorganize it. Aerospike did something different. Aerospike said, we're going to keep in memory just an index which has pointers to where the data is on disk. Basically, we said, let's treat SSDs and NVMEs, which we can access in concurrently, in parallel, and treat them like they were memory. Let's build the data and put that on those SSDs. And in memory, we'd keep a pointer that tells us where the data is. Okay, so that's the premise of it. That part of memory that we need in order to point at a record on the disk is always at the same size. It's 64 bytes. Regardless of the data size, it can be a kilobyte, it can be 2.5 kilobytes, it can be 10 kilobytes. But in memory, we don't store some portion of the data. We just store the pointer that tells us where the data is. So imagine that you have a user profile, for example, and it does a mixed workload of, let's say, some number. We'll see it in a second. So let's say that this customer showed me 1.3 billion profiles that they have. This is technically an ad tech company. Each profile was about 2.5 kilobytes. So that brought them to around 3 terabytes of raw data and 6 terabytes after the replication factor. And what they needed is to run 500,000 operations per second at their peak. And 375, that's 3/4, would be read. Then about 125, it's about 1/4, would be write. their latency at the P99, meaning 99% of their operation needs to complete under that latency, was 1 millisecond, like a single millisecond. So the way that they fixed it or solved it earlier was to put everything in memory. They brought in some in-memory database. They loaded everything into the in-memory database. They needed approximately 9 terabytes of RAM in order to do that. That was super expensive.
Yeah.
It was super tedious. That wasn't fun. It wasn't fun for anyone.
Yeah.
So let's see how we did that with Aerospike and what we did for Aerospike. Can you pull up the other one?
Your screen?
Yes, please.
Here we go. Oh, playing tag with my producer here. There we go.
Yeah. Can you see my screen?
Yep.
Perfect. So what we did is take the data. We created a cluster. It's a 5-node cluster. We loaded 1.3 billion objects of 2.5 kilobytes each, which is approximately 6 terabytes of data, like we said. And then we ran that mixed workload that we described, so 375 and 125, but we didn't do that at peak. We did it consistently over hours. And you can see that for hours and hours and hours, this thing has been running. And it wasn't the peak that we did. We did like a consistent throughput throughout like a substantial amount of time. And then we said, okay, for this thing, the latency that we'd see is those numbers are in microseconds. So the P99 for reading the data is 0.2 millisecond. And the write latency is half a millisecond at the P99. Wow. And the P99.9 it's even less than that. And if we think about it again, we say, okay, but this is an in-memory latencies. Those are latencies that I would expect to see in an in-memory database.
Right.
But we have terabyte of data, but we're only using 155 gigabytes of DRAM cluster-wide. So this is 2.5% of this. This is like a really, really minuscule amount of memory in comparison to the amount of data. So those latencies that you often see from an in-memory database provided from disk. And this is an awesome thing. This is Graviton 4 IAGs. I will talk about it in a second. And it's really interesting to see how this thing solves a problem that was there before. To answer the questions about the amount of metrics and the information that you can provide on like you can see on the database, there's a ton of information that you can get from it. From the throughput on each individual node, you can see that each of them has the exact same operation that is running, through the amount of data that is stored on each node and the distribution, the data distribution of everything, but also like obscure stuff like the amount of CPU that is being used, which is 3 cores out of like I think the 8 that this machine has. This is the IHG for extra large. Now, from the client perspective, the latency, including the round trip, if we look at the client latencies, the P99 for that is around half a millisecond, including the round trip. Again, this is not stored on the client machines. This is stored in a database outside the net, like in a different node in the network.
Right. Yeah. So, and then I was going to go somewhere. I see a question that came up right here. I think we're going the same place. So for like globally distributed deployments on AWS, what patterns are emerging for cross-region replication and failover for Aerospike?
So there are two main cross data centers, we call them, like cross regions. One is called cross data center application, basically. We say there are two clusters, Aerospike clusters, and they are connected, and everything is shipped from one cluster to another. And you can do it bidirectionally, from cluster A to cluster B, from cluster B to cluster A, and then you'll have an active-active, basically.
Right.
So that allows you, and this is baked into the product. This is like an integral part of the product. You don't need any other tool to do that. You just need the connectivity between the two data centers. So that's one thing. The second thing is when we talk about strong consistency, we can create a stretch cluster where one rack will be on one data center, the other rack will be on another data center, the third rack will be on a third data center, and then you can play around with that. The throughput will be lower because you still have like gap you'll have latency latency between the data centers, but you can create a consistent database across multiple regions.
That's
The
interesting.
latency,
So would you kind of think of it as like that third data center with the kind of the shared cluster being ideal for like where your hottest data is, and kind of distribute that there so it's equidistant from.
it's kind of different. The thing about you have US East, US West, and US Central that wants to show some information of, let's say, bank accounts. When you write the data, you want the data to be distributed, like be sent to all of the different data centers. You want that to be consistent. You want that to be available. You want that to be the latest and greatest information that you have.
Yep.
Now, when you read the data, you want to read it locally. You don't want to go over the network in order to read the data. You need to read it from your data center. So
Yep.
creating a strong, consistent cluster with like a stretch cluster, that's a unique proposition. This is something that not a lot of companies can do when talking about sub-millisecond operations for read and several milliseconds, let's say 100 milliseconds for write because of the network latency between different data centers. So
Yep.
it's something that is changing the way that you can deploy your cluster in a strongly consistent way. Most customers, by the way, don't do that. Most customers are totally fine with a cross data center application, asynchronous copy of the data, sometimes at 100 milliseconds, sometimes even less than that, 50 milliseconds. But they're okay by reading some non-consistent data for like a short period of time when it comes to data centers.
Makes sense. And I think, even talking about multi-cluster environments and having a write consistency of 100 milliseconds is still very, very impressive. So, uh, well done. I mean,
Can you go back to the slide? I'll summarize what we saw.
I'm sorry.
Can you go back to the slides so I can
Yeah. Let's go
summarize
back
what
to the
we
slides.
saw,
There we
and
go.
then we'll talk about Graviton 4,
Yeah.
which I am a fanboy of. So we
Nice.
saw 1.3 billion objects in the database stored on 6 terabytes of data. We saw a latency of sub 1 millisecond for the P99. We actually saw it around half a millisecond for the P99.94 reads. And then we saw 500,000 operations per second. With a footprint of a memory footprint of just 150 something gigabytes, which is an absurd 2.5%. And this is the live system. If someone in chat wants to mimic that and try it on their own, they can shoot me a message. I'll give them the script. They can run it by themselves. They don't need me. This is everything that they did just for everybody's consumption. Like people can run it themselves.
The Aerospike challenge, I'll call it.
Yeah. Now, the one thing that I didn't talk about, and I do want to talk about it because it's really, really cool, it's Graviton 4.
Yeah.
This system is running on the IAG4 extra large, and that's an awesome kind of hardware. So I said before that Aerospike, one of the things about Aerospike is that it utilizes the hardware very efficiently. And if the disks are fast and if the CPU is okay and everything is ticking, we can take everything from that. Like we gain so much performance out of that. We have the ability to utilize the disk in a way that even from performance perspective, we actually can read and write a lot of data based on what the disk can provide us. And the IAGs has an incredible disks. And the IAGs and the IJEs have an incredible disk. They have like really high bandwidth, really low latency, they're really stable. And that allows us to run really interesting workloads that we couldn't, like we could before, but we needed more hardware for that. In comparison, can you go to the next slide, please?
Yep. Let's go to the next
In
one.
comparison to the previous i4G, the Graviton 2, we've seen that we can do like 3 times as much operations per second with lower latency comparing to between those two different instance types. So from my perspective, and again, this is for me as a solution architect that goes to customers and showcase databases, this is something awesome.
Yeah.
Because the price difference isn't 3 times as much, it's like 10% difference between the old instances and the new instances. And if they're coming from Intel going to Graviton, it's basically exactly the same price. If they use the i4Is and going into the IAGs, they have the exact same price tag.
Yep.
So from them, it's pure getting more out of their database, getting more out of their systems.
Yeah, it's really interesting to see, you know, as we release these new generations of Graviton instances, like you have here from uh, Graviton, I think 3 to Graviton 4, you said?
I think
Um,
it's Graviton 2 to Graviton
2 to
4.
4.
Yeah.
Just the ability for us to really integrate the hardware into the overall stack, and you know we're developing custom chips, and you know our data centers are getting more and more optimized. And just a reminder for all of our viewers, like these Graviton is available for everyone. It's not just for ISVs or partners to use. So highly recommend taking a look at Graviton for you know certain types of workloads. We'll drop some links about AWS Graviton. Definitely something to look at to help optimize workloads, and you can kind of see a real-time use case and success story with Aerospike and the performance gains that they were able to get from Graviton on the Aerospike database.
Mm-hmm. From my perspective, the I generations, the i4, the i3N, the i4, the i7, they're all basically very optimized for databases. They're very optimized for disk-oriented systems. And once, I'm not sure if it's the Graviton part of it or the Nitro part of it that made the change, but the new generation ones are really optimized, both in the ratio of memory and disk, and really optimized to the way that Aerospike work. So again, if you need small footprint of memory but huge disk in order to keep your data, that makes sense for us. I don't know if it makes sense to all databases, but it definitely makes sense for us. And since we know how to maximize the abilities to maximize the hardware and to get the most out of it, it makes a lot of sense for us to recommend that and work with customers to use that. And again, from my honest opinion, this is where I'm literally doing all my sizing and my capacity planning and showcasing it. I recommend that to like anyone. Go take it for a spin. Go try it out if you're using this kind of a workload, and see where that lands you.
Yep. Let's see. So we've got a few minutes left. We do have some comments in the chat that I wanted to highlight, maybe, and then maybe we can start to talk about like how you can get interact more with Aerospike. I hear there's going to be some really interesting announcements coming soon from you guys, and I think you're going to be at reInvent too. So we have all that information on deck. Was there anything else that you wanted to kind of tie off before we go into some of these comments, Zohar?
No, I'm good with comments.
Okay, cool. Let's bring some of these up. So there's one from LinkedIn. This one: are there any limitations when inserting bulk records? That's a good one. Aerospike database will support indexing concept. How does that work?
There's in terms of limitations, there's not like real limitations, but if you want to go into low latency ingestion of data, then you usually try to bulk them in small enough bulks in order to put them into the database. So one of the things that we're doing is the client itself is interacting with all of the nodes of the cluster at the same time. So the bulk will basically depend on the size of the chunk that you want to write into the database and the number of nodes that you have, because we're going to distribute it across the multiple nodes. What happens when it goes to the server is that each bulk will be split into the individual records that needs to be served by that node. So it's not really bulk in the sense that we're like loading everything into a huge chunk and changing that. It's being done by the database itself. So bulk operations is just a batch operation for us. So there's some general limitations, but they're usually around the network and how the network handles those kind of huge packets.
Yep.
In terms of indexing, we support secondary indexes, and we support both like regular string and integer, but we also support secondary indexes on like more complex data types. So we can create a secondary index on the items of the list or the values of a map. So that's or an expression, like some function-based index that's there.
Yeah, that's really exciting. I mean, you can kind of see my grin here, but that makes it so much more versatile to be able to support things like that, and interact with your data more efficiently.
Mhm.
We have one more. We have another question here. Does cross-region sync affect latency at all? I think that's when we were talking about multiple clusters, things like that.
So the cross data center application isn't affected at all. The cross data center like transmission of the data into the different is being handled by putting into a queue, and then the queue takes that from the disk, and that's it. So from the client perspective, the cross data center application doesn't do anything for your transaction. It's not in line with the transaction. When it comes to the global transaction system, then you'll need to write to the other side, and you want to confirm on the other side. The premise of it is that you came from a strongly consistent system. They want you to acknowledge that the write has been done on the other side. So we can solve the speed of light problem. So if your data centers are like far between themselves, there's
Yeah.
a latency, like um, like a natural latency between them, and we do twice the latency. We need to go one way and come back with the acknowledgement.
Yeah.
But in
Yeah.
general, for region sync, for cross data center application, the answer is no, with no impact at all.
AWS has been trying to solve the speed of light issue as well. We're
I've been working on it as a side project, but
exactly. Just with the extra Raspberry Pis that we have laying around and stuff like that.
exactly.
Got another one here. What is the maximum number of client connections supported by the Aerospike database?
The highest that I've seen was in the hundreds of thousands. So I have a customer here in my region that they are using a non-cloud environment. They're using their own bare metal. They set the limit at like 700,000 or 800,000, something like really crazy and obscene. Most time we recommend to have no more than, let's say, 100,000 connections to the database, basically just because the cloud providers would limit your packets per second at some point. So around those numbers, but the numbers in the hundreds of thousands, like, let's say tens of thousands, that would be more accurate.
Got it. And then I think we have time for one more question, and it's sort of a long one, but it's important because security is really important, and this one kind of touches on that. So I'm going to bring this up. I don't know how much this is going to. Yeah, we're still here somewhere, but it says it's basically talking about how it affects security posture. Shared responsibility model, AWS secures information layer, customers and vendors share responsibility for the data and application security. How does Aerospike manage that overlap and the security measures that are in place?
Okay, so this is a lot to diffuse. So let's
Yeah.
start with the easiest one. I said it before, and I say it again. Aerospike at its core can be self-managed thing. Like you can download the software from our website and install it in your VMs, and then the security is like we have user and password, and we have like encryption, and we have like TLS for the interconnection, like to the clients and between the nodes. But security will basically be on you. You won't give that to someone else. It's not like you're putting it somewhere else, and someone else needs to, and then share responsibility. There's no shared responsibility if everything is in your backyard.
Yeah.
So there's no shared data. Having said that, we have two different other models that we can discuss about deploying Aerospike. One is called Aerospike Cloud, which is the big announcement that we're doing. This is a shared responsibility kind of solution that is going to be GA next month, and people will be able to go to it. And there's an early access now for people who wants to try it out and play around with the database, running the hardware, like running the VMs outside of their realm and outside of their account. But there's also one that is more, we are responsible for your data without accessing your data, which is Aerospike Cloud Managed Service. It's a service that we've been running for, I think, maybe 5 years now. So basically, we are running the database in your environment, in your organization, under your account. So there's a lot of ways to do that. In terms of just general stuff for database and the look of security, we have federal customers. We have customers that we actually harden the database specifically for their use. So it's FIPS compliant. We know how to encrypt the data at rest. We know how to encrypt the data in motion. We know how to give permissions and security RBAC secure permissions, and so on. So the database isn't just, let's say, a key value that you just put it out there. It's actually thought of as a database, and because of that, we have a lot of orchestration and mechanics to give that abilities to financial companies and federal as well.
Yep. Yeah, and I think there's some other links here. There's if you want to get started, I think one place to get started if you're going to reInvent, if you're in one of these industries where security is really one of those top priorities, especially if you're in compliance and regulation needs, you can find Aerospike at booth 1838 at
You can
reInvent.
find me at the Aerospike booth.
You can find the man himself at reInvent at booth 1838. Talk about your use case. There's also you can find out more on the AWS Marketplace. There's a link for that, and then I think there's a hands-on workshop series that we have here as well to kind of learn a little bit more about Aerospike and get hands-on. So
Yeah,
lots of cool links.
and specifically in the AI world. So this is the new workshop that we've been working on to showcase Aerospike in the world of AI, and it's not a new thing for us. We're not like AI sugarcoating it. We actually been doing AI and supporting AI systems for I think at least 3 years now, or 3 or 4 years, even before it was like rebranded AI.
Yeah,
So
that's super interesting. It seems like you're at the cusp, at the brink of every kind of breakthrough that you can between databases and also graph databases for real-time fraud detection, all of those AI use cases. Super interesting stuff. Really great conversation. Really appreciate the time, Zohar. I think we do need to wrap. So I'm going to go ahead and say thank you once again. Thanks for everyone for the questions. It was really cool to see all the different interactions. Any last words, Zohar, before we wrap?
yeah, thank you for having me. I had a blast. I really enjoyed it. I hope if people have questions, they can reach out to me. I'm on LinkedIn. So feel free to reach out to me and ask questions and interact with us. And if you are at reInvent, come and say hello and tell me that you saw the stream, and I'll reconnect it with the real world and everything.
Sounds good. As for me, want to thank you again. Hope you have a great day, and we will see you soon.